Good morning, everyone, and welcome to the November edition of Third Thursday of the BC Wine Grape Council R&D Committee monthly presentations. Today, a topic that's high on everyone's mind is temperature stress in the vineyard. And as a presenter, we have Dr. Simone Castellarin. He is a professor at the University of British Columbia and a Tier 2 Canada Research Chair in Viticulture. At UBC, he also serves as the Associate Dean Dean of Research of the Faculty of Land and Food System and as co-director of the Wine Research Center. His research focuses on how the climate affects grape ripening and quality. And in 2009, he received the Rudolf Hermans Prize from Geisenheim for outstanding scientific achievements in horticulture and viticulture. And today he's presenting on the influence of temperature and heat stress mitigation strategies on grape quality in British Columbia vineyards. Welcome, Simone, and thanks for coming.
Okay, thank you very much, Kathy, and thank to all of you for participating to this seminar. I will introduce later my students, but I will just say that the data I'm presenting today are the data produced from two of my graduate students that are here present in the call, Nik Wilson and Sarah Davis, who have been working with me on this project. And so they are in the room, and later on, maybe during the question time, they might also intervene if we need to clarify some specifics of the methodology. So our study is focused on temperature effects, on quality and physiology, and also on what happens when we have heat waves or heat stress events, and looking into ways to mitigate potential negative effects of this phenomenon. You probably have seen this picture several times. It's a study from 2013 that started investigating how climate change was going to affect viticultural production or suitability of wine regions across the globe. And one major output of this paper was that we're forecasting that regions where we traditionally grow grapes, like Central and South of Europe, might become less suitable for viticulture due to extreme events, and also temperature that might not be suitable for some of the varieties we are growing, versus the observer, they predict a shifting of viticulture toward northern regions, including in this paper was the Pacific Northwest and the Okanagan Valley. Obviously, when we deal with forecasting the effects of climate change on viticulture, it's quite complex. I think, in fact, this study might have neglected also some how important could be extreme events also in the winter time, where then we can observe cold damage. So we have to consider not only increases in temperature in the summer, but we have to consider how extreme events during the winter might limit this expansion toward north of viticulture. There was a study a couple of years ago conducted by the University of Toronto, Hewer and Gaud, and they analyzed the climate in the Okanagan. Actually, they use Kelowna as a proxy for the Okanagan. How this climate is gonna change with a modeling exercise that was predicting changes in temperature in the future, and how these will potentially affect viticulture. In fact, they use some parameters that we normally use in viticulture, like growing degree days, heavier temperatures during the growing season, extreme heat days. And I'm going to present a couple of graphs of what they forecasted, but I would like to highlight that they use extreme heat days as days where the temperature, maximum temperature is above 32 degrees Celsius. I believe this might be not so extreme for grapevines. We do grow grapevines in different warm regions. Obviously, different varieties might be more or less adapted to extreme heat condition, but maximum temperature of 32 degrees Celsius, as I will also show from our own experiment, might not be so limiting for the grapevine. We believe that probably 38, 40 is where we really might have some detrimental effects on the physiology of the plant. But regardless, what this study have shown is that in the past 50 years, there was an increased trend in temperatures, again, using Kelowna weather station, and a progressive increase in the average temperature, about 2 degrees Celsius from the 70s to the current days. They also predicted what could happen to the maximum temperatures in that region in 2050, in 2080, depending on different models of climate change, more, well, a model that might imply some mitigation strategies. So where we forecast that climate change will not be so severe if we mitigate the changes in CO2 emissions, and a model, the orange one, that actually forecasts significantly increase in CO2 emission, and therefore higher increase in temperatures. And basically what they predicted is that in 2050 we might have an average temperature in Kelowna of potentially 1 or 1.5 degrees Celsius higher during the summer season, during the growing season for grapevine. 2080, this can go to 25, so 2 degrees Celsius on average, for the maximum temperatures, or even more, like even 4. So that could be quite extreme scenario. They also forecasted a number of days above a certain temperature. Here is again 32 Celsius, which I think is probably overestimating the effect of such temperature on the grapevine physiology. But the number of days at that temperature are going to increase significantly according to these prediction models. I would like actually to focus to an exercise that we have done in our laboratory in analyzing. We are not climatologists. It was somehow a simple analysis. I know there are many scientists at UBC and Agricultural Food Canada and other research centers in British Columbia and Canada who analyze weather data. But we did collect data from 2012 and 2023 from a vineyard in Oliver. That these data were shared by Andrew Peller Limited. So we are very thankful. And we did an analysis of understanding in each month of the year how many days we have maximum temperature that exceed 35 degrees Celsius or 37 degrees Celsius or 40 degrees Celsius. And here you see just an example of 3 years, 2012, 13, then 2024. We actually did the analysis for the whole period. And you see that when you use 35 degrees Celsius in July and August is where we have our hot days. And obviously, many of you are viticulturists, winemakers, work in the vineyard, know better than me what is the situation. I'm just showing some data about that. And so when we got to 37, 2012, we had 7 days above with maximum temperature above 37 in July, August. But let's focus on 2024. It was the current season. So we had a lot of warm days actually in July, and with temperatures that were about 37 maximum for 18 days. Sorry, 35 for 18 days, actually 37 for 17 days, and above 40 degrees for 4 days in August, and excuse me, in July. And if we go to August, we had again 10, 5, and 2 days above 40 degrees. So we are experiencing temperatures that we believe might be detrimental for the physiological activity of the grapevine. So temperatures are above 35, 37 degrees Celsius maximum. And here is another summary where we counted the heat wave events during these 12 years. And for heat wave events, we arbitrarily decide to simulate, to call it heat wave about 35 or 37 or about 40 for at least 3 consecutive days. And you do see that we have such events pretty much every year. If we consider the current season, we had only one event that was actually around 4 or 5 days in July when our maximum temperatures were above 40 degrees Celsius for 3-4 days in a row. And this data come from, again, from Oliver, from the Oliver Osoyoos area. So we do experience heat waves, what we will consider a heat wave that is detrimental for the grapevine. If we consider 40 degrees Celsius, they are not as frequent, at least in the past 12 years. And again, this is not a proper climate analysis. I'm not a climatologist, it's just representing what was going on in a vineyard in Oliver in the past 12 years. But if we consider 37, we have way more frequent heat wave events that could happen in July, August, or June, July, August. So what happens to the grapevine when there is a situation of high temperature? Well, if the temperature increase, or generally in warm climates, normally we have more, an increase in the photosynthesis, in the vine metabolism. So if we have warm temperature, grapevine likes them and actually produce more sugars and improve the photosynthetic rates, but also, like we will see in the next slide, tends to improve the ripeness of the fruit. But when the temperature go above a certain threshold, and this threshold are around 35 degrees Celsius, as I said, it might depend on the variety, we tend to have negative effects on photosynthesis and the capability of the leaf of fixing carbon, producing sugars. And we can also have negative effects like producing of reactive oxygen species. So basically oxidizing or several of the components of the cells and basically impairing negatively and permanently impairing the capability of the leaf of doing photosynthesis. So when the temperatures get very high, then we have problems. And actually we have opposite effects, less sugars and less ripening. We did ourselves some studies in Gewürztraminer a couple of years ago where we exposed in greenhouses grapevines to heat wave, this is not greenhouse, it's a grow chamber. So a box where we can put plants and modulate temperature how we want in a consistent manner. So when we expose plants for 5 days at 4 days at temperatures that are around 40 degrees Celsius, and we compare with plants that have are exposed to maximum temperature around 30 degrees Celsius, what we see is that PN is the photosynthesis rate here. There is a drop, actually quite sudden drop in photosynthesis. Basically, the plant stop photosynthesizing or really reduce to minimal level the photosynthetic capability. And what also it does is loses more water, and we'll see that from other figures later on. So there is a higher water consumption that might have implication for irrigation. We'll talk about later. What happens in the berry is, again, if we have just a warm climate, if we have warm temperatures but not too high, then we have, I would say, faster and in some cases like stimulated ripening, meaning more sugar and more ripe aromas on our fruit. But if the temperatures become too high, like again above 35 and so, we tend to actually have less sugars, smaller berries, and also reduced levels of malic acid and severe effects on the production of quality-related compounds like color and antocyanins. Here is a study we did ourselves, again in growth chambers from Merlot some years ago, excuse me, and we observed that I'm trying to have the cursor here. Let's see if it comes. Yes, when we have plants that are at low or medium temperatures, 20, 25 degrees on average during the day, we have a high anthocyanin production up here. But when the plants are put at 35 degrees Celsius, anthocyanin really are low, and so we have a strong impairment on the pigmentation of the berries. We have what we call the decoupling effect, that at the same sugar level, that is, for instance, here 20 degrees, we have very low anthocyanins when the plants are grown at high temperature, and actually optimal anthocyanins when the plants are grown at low and medium temperature. This also shows one thing, that when we study effects of the temperature on quality of the fruit, we cannot just summarize as an effect for all the metabolites we are studying. The effects can be different if we are considering sugars, organic acid, anthocyanins, and aromas, for instance. And there is a lack of understanding, for instance, on the impact of high temperature on aroma production, versus we do know quite well what happens in terms of phenolics and anthocyanins. So I'm going now into the project that we have been conducting in partnership with several industry members and with the sponsorship of the BC Wine and Grape Council and the Canadian Grapevine Certification Network, and Agriculture Food Canada. This study is trying to understand how we can deal with heat stress when we had a heat stress phenomenon. And we want to understand, first of all, we grow a lot of varieties. Are some varieties that are more sensitive or more tolerant to heat stress event in vineyards? Then how we can play with, or how we can mitigate a heat wave in the vineyard by using irrigation to increase the evaporative cooling, basically, and make sure that the plant is transpiring so that the temperature of the canopy doesn't increase too much. But this project also aims to understand what happens if we are applying moderate depth irrigation, or what happens if we don't have enough irrigation to increase the amount of water we put in the vineyard during a heat wave. What happened to the physiology of the canopy, and what happens to the berry and the quality of the berry. And then we want to investigate if biostimulant products that have been somehow promoted, or we hypothesize might have a positive effect in boosting those plant constitutive system to cope with heat, are working or not in grapevine. So basically, there will be spraying, foliar sprays of these biostimulants and in vineyards to understand if they actually work in mitigating the impact of a heat wave on the canopy and on the fruit. And we aim to work on, use chitosan, salicylic acid, and a couple of other commercial products that are now available, and including using kaolin, like the product that we are already using in our vineyards to protect from radiation and protect from heat during the summer. And finally, another thing that this project investigates in the impact of temperature on quality. And generally speaking, high temperatures, what are high temperatures doing in terms of production of phenolics, but more important, production of aroma in the grapes? Those are things that we really don't know very much. What is the impact of a heat wave, but also generic very high temperature season, like 35, 37 degrees Celsius? What are these inducing in terms of production of aromas in the berry? So research question, we have these projects. How do important BC varieties differ in heat tolerance? Which mitigation techniques are best for dealing with extreme heat events? How important it is irrigation in coping with that? And then how these biostimulant products that are commercially available are helpful or not? And again, how quality phenolics in aroma respond to heat stress. I will start by saying what we started doing this summer. Obviously, you know, this was a special, particular, hopefully unique summer for many of you, and by reflection also us, in the sense that because of the winter damages, a lot of vineyards where we were supposed to start the field, actually all the vineyards where we were supposed to start the field experiments, well, didn't have a canopy or didn't have production. So we spent time in identifying those vineyards. I will talk a bit about that later on during my presentation, but our focus was in greenhouse and growth chamber experiments. And this is where those experiments were already planned in our proposal, but so it worked good that we focus on those, and a strong focus was to produce the plants that we need for the experiment. So we produce rooted cuttings from 10 different varieties. These varieties are varieties that are grown in the Okanagan. I'm pretty sure you recognize them: Cabernet Franc, Merlot, Pinot Noir, Pinot Gris, Chardonnay, Riesling, Viognier, Gewürztraminer. But also we included a couple of varieties that are less grown, like Malbec and Semillon, because they have some interesting behavior when they are exposed to stresses, and we wanted to have those varieties as a reference. We produce about 450 vines. Those are root cuttings. You see somehow the process of producing them, rooting them in pots, and then eventually by the end of the season, they already have nice shoots that will become productive cane for the next season. Next season, we'll use this plant for growth chambers experiments that will consider both stresses on the canopy, so on the leaves and the fruit. But this season we were already able to perform some experiments in these growth chambers. And here you have a picture of a growth chamber where you see that we have vines inside. So inside this chamber, we can control temperature, partially relative humidity, and light, and so we can simulate heat waves and heat stress events. We started doing these experiments, like I'll show later, but we focus only on the physiology of the leaf because these plants obviously didn't have fruit yet. Next year I'll say later what we do next year actually, but we'll have more of a focus on the response also on the fruit. So this project is on understanding the different heat tolerance of varieties used in BC. Is led by Nik Wilson, a PhD student who started in January. Is also present in this call. In the growth chambers, we studied the effect of heat waves in this first experiment. A heat wave was 40 degrees Celsius during the day, 25 at night. In this case, we use a long heat wave, even though probably 4 or 5 days of a heat wave will be the representation of what happens normally in the Okanagan. But we also want to see what could happen if we have a long heat wave, like 8 days. And we compare this heat stress or heat wave with control chambers where plants are exposed to 30 and 15 degrees Celsius during the day and night, respectively. This year, the focus was on wine physiology, and wine physiology, we studied photosynthesis, tomatal conductance, transpiration, and what happens on the leaf temperature when the plants are exposed to this. But I'll focus on this graph. This graph actually represents what happens to the photosynthesis of Cabernet, Chardonnay, Riesling, Viognier, Gewürztraminer, Merlot, Malbec, and Semillon when plants are at 30 degrees Celsius. So a relatively warm, good day in the summer, and actually quite warm day during the summer. And when plants are exposed to 40 degrees Celsius is the white dot. And so you see that some varieties like Cabernet Franc, Riesling, Malbec, Semillon have quite big drops in the photosynthesis. So in control conditions, the photosynthesis level here are, the value is 8. We don't have the unit, micromole CO2 per second per square meter of canopy, but basically you see that when we expose to 40 degrees Celsius, we have half of the photosynthesis. And these are well-irrigated plants, so plants that have plenty of water. There is no, by any means, any other stress effect. And so you could see how you could appreciate that some varieties drop photosynthesis. They tend to recover after several days a bit. Some of them, they do recover, like Riesling here. Others, they don't. But in a short heat wave condition, we have that some varieties have half or less than half photosynthesis. Other varieties are less affected, like Chardonnay was less affected, Gewürztraminer, Merlot. And so it's interesting, and this is actually the goal of this project, to study how these the variety respond different in terms of photosynthesis, which one are more susceptible, how they recover. And I'm not showing this data, but we started collecting this data, how they do recover after a heat wave or a combination of heat waves. Because we did observe before that when plants are exposed to 2 heat waves in a row, they might have long-term damages to their photosynthetic capability. And this is probably when we can observe more more damages also, or more effects on physiology and quality. But so take-home message of this, varieties respond differently to heat stress. Some of them are more tolerant than others. We also conducted another experiments where I will not go into the details of the physiology and biology of the system, but basically those are experiments people conduct in different plant systems and crop systems to understand how leaves tolerate heat stress. And so to understand basically what are critical temperatures for the leaves, where the photosynthetic apparatus of a leaf really gets damaged by heat stress. And in this temperature, in this study that is done in a water bath, and actually we have a series of about 6-7 water baths that are set at, they have water, different temperatures, and leaves are basically collected from the vines in the greenhouse, put at different temperatures, stimulated with light, and there we do some measurements to understand how the photosynthetic apparati are working and how much they are affected by these temperatures. So as I said, these studies are conducted normally, have been conducted in different plants, in plant species, including crops like tomatoes, blueberries, etc. Normally speaking, you see that and those plants that when temperatures, depending on the plant and depending where how the plant is adapted to warm environments, but those studies are generally showing that temperatures around 30, mid-30s are really detrimental, are really detrimental for the photosynthetic apparatus. That means that when those plants hit those temperatures, the photosynthetic apparatus cannot recover, and photosynthesis will be impaired afterward, even if the temperature gets lower. Now, the interesting story so far, but this is just, I would say, a preliminary experiment because we want to test all the 10 varieties we have produced and repeat the study, is that by comparing Chardonnay, Pinot Gris, Cabernet Franc, and Riesling, we observed that this ratio, FV to FM, I'm not gonna explain what this relate to. It relate to the fluorescence of chlorophyll from a leaf. So when these values are high, it means the apparati are doing fine and they are not damaged. When they decrease, it means that damage starts occurring on those apparati. And as I said before, in other crops, we observe damages at around 30, 35, 28. But here we observe in grapevine that until 40, 47, we don't see permanent damages on those apparati. So basically, grapevine is very tolerant and tolerates quite well high temperature. And we really need to push the temperature to 45, 47 before we observe damages that are permanent on the leaf. And those temperatures are not normally recorded in our vineyard. However, we did observe that some varieties, and Cabernet Franc is one of them, tend to start decreasing or having decreasing this value and having this apparati damage earlier than others. So we do observe that some varieties are more sensitive than others, still quite safe, like at 40 degrees Celsius, none of the varieties had any damage on their photosynthetic apparatus. But when we went to 45, for instance, Cabernet Franc had a decrease, so had a significant, let's say, potentially was not tolerating those temperatures. So the future plans for this project I've been talking about are to now assessing the impact of heat wave at different physiological stages. Next year will be possible because next year we'll have these potted plants that will produce potentially 5, 6 clusters, and we can move these plants into these control environments and expose them to heat waves before veraison, after veraison, and assess the effect on the physiology, photosynthesis of the canopy, and then also the quality, including phenolics and sugars, organic acids, and aroma of the fruit. We will keep testing the thermotolerance of all our varieties to identify if some are more or less susceptible, which one are more or less susceptible. We actually find that our data in this very, laboratory setting, extreme laboratory setting, because actually we use water baths where we put leaves, so they are detached leaves, etc. But they do match the experience that some growers have in terms of finding the Cabernet Franc is sensitive to heat, etc. So we do find that there is a match of what we find in this control environment experiment and what anecdotally we know from vineyards. And so we believe it's a good strategy to compare varieties in a control environment setting. And again, next year we'll be able from next year to include berry quality data that are obviously very interesting and important. So our project also aims to study mitigation strategy in vineyards and how we can, again, play with irrigation, or how much irrigation will be important and will allow to mitigate heat stress in vineyards. And the first project I'll talk about, this will start in 2025, and we hope we can repeat the experiment for 3 consecutive years. We have identified 2 vineyards, actually 1 vineyard that have these 2 varieties, Cabernet Franc and Syrah, that we want to compare because we know that somehow might have slightly different responses to water deficit, to moderate water deficit. So we were interested in seeing varieties might behave differently. But we also know that according to the grower who is hosting the experiment, Cabernet Franc in that vineyard have been suffering from heat stress in previous years. So we want to see how, with the irrigation treatment we are going to apply, we can eventually mitigate, or potentially also if we how much damages we'll have if we are if the plants will be under moderate depth irrigation. In fact, what we want to do is we want to compare two we'll see if we can implement 3 irrigation treatments. One is plants that are well irrigated, and we'll use evapotranspiration models to understand what is the 100% of water the plant is transpiring during a heat wave event, and we'll apply 90% of or 100% of this water to make sure that the plant has plenty of water to transpire. This transpiration of the canopy is actually generates a cooling effect on the canopy, and so helps the canopy coping with high temperature. But we also want to see what happens if we are applying some certain level of moderate water deficit. We consider 30% of the total evapotranspiration, like a good spot to have some moderate stress on the plants, but not too severe. But we might also consider intermediate treatment, because we do know that when we have some moderate water deficit, the grapevine can cope okay in several cases and actually stimulate the quality of the fruit. And again, we are not talking about severe water deficit effects, but we don't know what happens when the plant is also undergoing heat stress. So this project aims to see if, also to compare if the plant is slightly stressed, will it be able to cope with heat stress, or what are the effects in terms of physiology and quality. And the goal is actually to apply our irrigation treatments just before predicted heat waves, and then during this time collecting physiology data like photosynthesis, etc., and samples of fruit, and analyze what is the quality of this fruit, in a condition of well irrigated plants versus moderate water deficit plants. The other project will start next summer. We have identified 2 vineyards, Cabernet Franc and Riesling, in the Okanagan Valley, and is testing the mitigation strategies based on biostimulant products. So the biostimulants are products that, from literature and also from, they are already used in commercial settings, not necessarily only in grapevine, but in other orchards. So those are products that stimulate defenses of the plant towards stresses. And in some cases, some of these products, they are believed to stimulate defenses of the plant toward heat stress. And we are going to test some of that, chitosan, salicylic acid-based products in the vineyard. We also probably will include a couple of other products that are available in the market, and compare that with kaolin, that is the product we are using, and control treatments, that means the usage of no product. And what we will do is we'll spray these products before heat waves again, and then during the heat wave collect physiology samples to see if these products help the plant coping with heat stress in terms of photosynthesis, but also samples of fruit that will be analyzed for the quality. And obviously, harvest will be the time where we can assess if these products, as well as the irrigation strategies that we applied before, really have a positive effect or mitigation effect on a potentially stress. Now, this is a prototype of the prototype. This is what we plan to use in case we don't observe next year heat waves in the Okanagan. As I said, heat waves in the Okanagan are relatively frequent. If we consider 40 they are less frequent. But if we consider temperature around 37, 38, those are pretty much happening. Those heat waves are happening every year. However, we have been working this summer in building this portable and also removable, that is more important, little greenhouse system that is supposed to warm up the canopy and the cluster zone in the field without, the goal will be to do so without affecting the radiation that is intercepted by the canopy. Actually, our goal will be to have to lower the height of this infrastructure to levels that are lower than the cluster zone. So we would like them to be smaller and produce air here that will be eventually released on the topper part, so that we can, if we have warm days in the field, actually induce even a heat wave on the canopy by warming up the canopy 2, 3, 4 Celsius more than air temperature of the given day. So it's a way to simulate heat waves without affecting radiation and light, and to do so in a way that we can remove this small infrastructure after a few days, so that the tractors and the growers can keep farming in the vineyard. There have been similar infrastructure have been used in Australia to simulate heat waves. Those were permanent and very fancy with actually a hard frame, iron-made frame, and is sort of little greenhouses that are set in a vineyard permanently. But we don't want to go that way, because obviously that will generate disruptions of the operation for the growers that are hosting our trials. So that's another project we did this summer. In the meantime, we have been waiting for starting the field studies next year. So what we'll do in those field studies then is, again, I said it before, characterize the physiology of the plant. I'm not going to go through all these things with, well, photosynthesis, stomatoconductance, and use the pressure chamber for water potential. And then take the fruit, bring the fruit back to the lab and analyze sugars, organic acid, aromas, phenolics in the lab. Now, before I move, well, in the last 5 minutes, 4 or 5 minutes, I will just briefly talk about another project we have done that relates to this funded project, but is actually funded by NSERC and is aims to understand what is the effect of heat and drought, particularly in combination on the quality of the grapes and particularly on the aroma of the grapes. This project is led by Sarah Davis, a master's student in our plant science project. Sarah is also here in the meeting. And again, the focus of this project is on the aroma of the grapes, even though the data I'll present today are only related to the physiology, but I'll explain why I'm presenting them today. And I'm not presenting the aroma data today because we just harvested the fruit 3 weeks ago. So we are in the process of analyzing those aromas. So the focus will be on terpenoids, volatile terpenes in Riesling. Riesling linalool and other monoterpenes are important for Riesling. Other terpenoids like sesquiterpenes are important for other varieties, but the project is focusing on profiling these monoterpenoids and sesquiterpenoids in Riesling. And actually Viognier as well. So we are considering both varieties. Riesling and Viognier both have the one quality strongly impacted by the production of terpenoids that affect the aroma, the stone fruit of aroma of Viognier, and also the linalool is a key compound for Riesling. So Sarah is using these big grow chambers that are basically rooms where we can set up the temperature the way we want, and is putting these Riesling and Viognier plants that have clusters, as you can see in this picture, at high and low temperature. So high means that the lower temperature in the night is 22, the higher is 35. Low temperature means that at night they reach 12 degrees Celsius and 25 maximum temperature in the day. So we are comparing Riesling and Viognier grown in a relatively warm, but not I would say cool climate region versus a warm, hot climate region. And the goal is to see again the difference of how this plant behaves. But that the interesting part of this project is that we do factorial experiments, so a combination of heat and low temperature and well water and plants, or plants that are exposed to water deficit. We are particularly interested in understanding what happens when the plant is exposed to both stresses, how this combination of stresses affect the quality of the fruit. And so the plants were exposed to those stresses alone and in combination. So we have heat stress, well water plants, heat stress, water deficit plants, low temperature and water deficit plants, low temperature well water plants. So we have all the condition for 20 days during ripening. And we have several replicates for each treatment. Sarah has conducted physiological measurements that I'm presenting today, but also will be conducting, as I say, the quality measurement on the fruit really soon. So what I want to show here is both Riesling and Viognier. On the top is the water potential, stem water potential during the day remains quite high, meaning there is no stress. Those are the well-water plants. When you expose the plants to water deficit, obviously the water potentials are lower. But as you can see in Viognier here, the water potential, gets much lower when there is also a combination of heat stress with a water deficit. So obviously there is water deficit, even though we were irrigating to bring the soil water content to the same level. When the plant is also exposed to heat stress, will have a lower water potential. What we see on carbon assimilation is this. Actually, water deficit, when we have water deficit, but these were actually moderate level of water deficit. When we have, let's say, water deficit and low temperature, the plant actually doesn't get so stressed in terms of photosynthesis. Photosynthesis remain high. But when we have water, I was sorry. I'm mistaken. So there is no water deficit. The plant I have high level of photosynthesis even with high temperature. But what happens when you have like water deficit is that low temperature have some reduction in photosynthesis. But if you have also high temperature, the reduction in photosynthesis is dramatic, and basically you are going to zero photosynthesis. So obviously the effects of water deficit are much stronger if you are under a warm day or under high temperature. What happens with transpiration? The plants under high temperature, even if when they are well watered, they transpire a lot. So they use a lot of water. And so what it means is that this graph is telling us that basically we have to adapt our irrigation to the temperature we have. Here an example of how much water was lost from our plants per day during the experiment. So basically, you see that most of on the lower part of the graph, those are the plants that are either well exposed to low temperature, or they are exposed to water deficit and low temperature. So they use not so much water. But as soon as the plant is exposed to high temperature and there is enough water, you see how much water they use. pretty much the double amount of water. So if we have high temperature, we use double amount of water under well water conditions for irrigation if we want to keep the plant not stressed. But interesting enough, I will say that obviously when we have a moderate water deficit, we use less water. But when the plant was exposed to well water condition and low temperature, pretty much the water use was the same as under water deficit condition. The increase was low temperature basically will not require so much water to keep the plant going. I will go very fast here. There are strong effects of temperatures on tetratable acidity. So high temperature water deficit, low tetratable acidity, high temperature well water, low tetratable acidity. These are things that probably you already know and they are well known in literature. We do not observe strong effects on sugars. I want to remind this is the sugar level at the end of the experiment, not at harvest time, but we do not see significant major effects on sugars by these low versus high temperature treatment. I really have to rush. I am understanding that here I'm going out of time. I will say that future experiments will focus on the quality of the fruit. And before I conclude, actually, could be sort of a conclusion slide. The last part of our project is led by Dr. Nathaniel Newland, and is actually to model what happens to the fruit quality under different temperature and climate scenarios. And to do so, I'm not presenting this data because this year we just started some preliminary experiments due to the fact that the majority of vineyards in the Okanagan didn't have production. But what we did this year was to identify vineyards in the northern part, central part of the Okanagan Valley, central and lower of Riesling. And these vineyards will be surveyed for quality and temperature and other climatic effects to see how well berry quality and berry aroma responds to the different climates of the Okanagan. We reach out to several of you. I'm not sure who is in the room now because I don't see, but several wineries. We have a pool of 5-7 wineries that have agreed to host our experiment, and we still miss some Riesling vineyards. So if you have some Riesling vineyards that you think can be used for this modeling exercise, this project is very limited intervention in the sense of we don't generate disruptions in the vineyard. We basically collect only some measurements and some fruit. And so we are still looking for vineyards that to include it in this study, but we are very hopeful that from 2025 we'll start this study and conduct it for 3 seasons. I would like to thank you for your attention. Sorry I went long, and obviously the sponsor of this activity, and also Andrew Peller for offering some climate data that I presented today. Thank you very much.
Thank you, Simone. We have a couple of questions. I'm going to ask my question first, because I can. When you talk about multiple heat waves having compounded effect, what's the time frame between the heat waves? Is there, right? It's the multiple heat waves.
Oh, yeah, that's a very good question. And I'm not seeing, excuse me, I'm not seeing who asked, and I'm sorry if I don't quote and direct you, but it's all good. I'm seeing my screen, it's all good. But so our experiment that we did a couple of years ago had a heat wave before and one after variation. So the two were before and after variation. And basically we observed that after the second one, so after the first one, we observed a decrease in photosynthesis, but a full recovery. But after 2 heat waves, we do observe that there are more long-term damages in terms of photosynthesis, and also some larger changes in terms of fruit quality. So they were apart. They were not very close. They were probably 15 days apart. Let's put it this way. But it is certainly something that if we have time and energy within this project, we want to try to explore more and have a combination of heat waves versus one to gain more insights on this.
Yeah, because our heat dome was so early in the season, right? That was really unusual. Okay. Chris Mark has asked, when you're looking at the temperature effects, are you looking at humidity as well as VPD effects?
Yeah, so these are very good questions. So basically, in our project, in the grow chambers, we do not control humidity so efficiently. So what happens is that, but is okay, people might have different ideas. I'm saying my idea. So obviously, when we conduct an experiment, it would be great to have everything consistent, but the specific factor we want to modify. So same humidity, same I don't know, water levels, etc., but different temperatures. So what happens in a grow chamber, unless they're very sophisticated one, is that when you play around with temperature, all of a sudden, because humidity relates to temperature, you decrease the temperature is higher, you have lower humidity. So we don't control that. But I do believe, that's why I'm saying, I do believe that this is not a big issue, because this is what happens also in real case scenarios, unless you are in the tropics, where if you have high temperature, normally it's drier, slightly drier than if you have a lower temperature. So we would like to be able to control humidity, but we cannot. And certainly, yes, there are different VPDs inside our chambers that will relate also on the how much water is used. Our irrigation are based on soil, how much water we provide to the soil, so the percentage of basically a percentage of water compared to the full capacity. So this is what we are doing.
So, and you're recording the humidity, right?
Excuse me?
You are recording the humidity, so you do have.
Yeah, we have humidity data. We have all the data are recorded. Yeah.
Hans says, would you expect that leaf temperature would be a better predictor of heat impact than ambient temperature?
Can you repeat?
Leaf temperature, would you think that might be a better predictor of heat impact than the ambient temperature?
Leaf. Okay, good. Leaf. Okay,
leaf,
I couldn't catch the first word. Okay, so we are actually recording leaf temperatures on those vines. I didn't show that today. And it's I agree 100% on a physiological point. We don't have probably much time here today, but leaf temperature, berry temperature is not the ambient temperature. We know in the vineyard, for instance, we can reach 10 degrees, 5 degrees, depending on the organ, depending how much they are transpiring. So that's very critical. And I do believe that I agree that on the side of biosynthesis of compounds, what matters is the temperature of the organ that we are recording. What we do with the chambers, we are simulating that. I must say that in a chamber compared to a vineyard, because the radiation is not very strong, the leaf temperature and the berry temperature are quite close to the temperature of the chamber. So we have, a temperature that is quite consistent with what we are setting. In the vineyard, that's actually probably a tricky thing, but it's also tricky to do the experiment in the vineyard. You know that if you have 40 degrees or 35, your organ could be at 40 or 45 because of the radiation effect.
Yeah. And Kate was wondering about, in the first trial that you spoke about with the several varieties, if you're planning a sensory component, like will you have enough fruit to be able to evaluate the sensory?
No, so we don't. So the first trial is basically the comparison of the varieties, right? Is what we are planning is to do a very quite intense profiling of metabolites of the fruit, but we are dealing with vines that have 4 or 5 clusters maximum. because if we overload them, then also it's not good because the canopy is small. And so we could do some individual berry sensory trials, but doing a proper sensory trial is actually quite another project on the project. And I don't think we can perform that.
No, little future project.
Yeah.
We did it. We're in under the wire. It's 1 o'clock.
Yeah, I'm sorry about going longer. Maybe it's I included new slides, so I was not practicing too much about the timing. Yeah.
You don't need to apologize. If people have more questions, they can contact you either through Kate or directly. And we welcome people to do that. I think you do too, Simone.
Okay.
And
Yep.
Thank you so much for presenting, and thanks to your students for being here as well. And hopefully we see you all again.
Yeah, thank you. Maybe next time they can present instead of me.
Yeah.
Okay.
And thank you to everyone who attended. Again, it will be put on the web. The recording will be put on the website for future viewing. And December 18th, I think, is our next Thursday, 19th, December 19th. And that will be a CGCN Q&A. So join us for that, and we'll see you in a month. Thanks. Bye.
Thank you very much. Bye-bye.